So linear programming, the basics of it is you are solving a word problem that has a bunch of constraints, okay? And we are specifically finding, it says the optimal value for our solution, and that occurs at the vertex of the region that is possible. So we're going to have a bunch of inequalities that we're going to shade. We're going to figure out what is the actual solution region, and then we're going to figure out what is the maximum or minimum, depending on what the question is asking us, of those vertexes, okay? So your suggested steps here, we need to write our objective function. This is usually our, that's way too large there. Let's go, that is usually our profit or cost function, okay? And then we're gonna have a bunch of different constraints depending on what our variables are and what it says. After we figure out what all those things are, we are going to graph that region on our graph. We are going to figure out what our vertices are, so all of the corner points there. And then we're going to plug all of those values in to my objective function to see what is either our maximum or our minimum, depending on what the question was asking us, okay? So if I look at this example here, we've got the Charleston Company makes 2 products, MP3 players and DVD players. Each MP3 player, do we know what an MP3 player is? Yes? Okay, good. I love that. Anyone have a DVD player still? Yeah?
VHS.
Good. I love it. I love it. Anyone have those old little cassette tapes anymore? No? Okay. That's fine. All right. Each MP3 profit is $30, while each DVD player profit is $70. Okay. The company must manufacture at least 10 MP3 players per day to satisfy one of its customers. However, no more than 50 because of the production restrictions. The number of DVD players produced cannot exceed 60, and the number of MP3s cannot exceed the number of DVDs. There's a lot of things going on there. How many of each should the company manufacture to obtain maximum profit? So we're looking for maximum profit here. In order to do that, we first have to identify what are our variables. What is our X and our Y? What are we solving for? MP3 players and DVD players, right? So let's just say that X is going to be our MP3 players. And Y is going to be our DVD players. Okay? And now we are trying to maximize our profit. Okay? That's what the question is asking us here. To obtain maximum profit. So in this giant paragraph here, it's talking about profit where? Yeah, $30 for our MP3s. And DVDs are 70, okay? So we're trying to maximize that. So there's not going to be an equal sign. Our objective function, which in this case is our maximum profit, so same thing as maximum profit, that we're going to test is going to be the equation, or the expression really, 30x plus 70y. If I plug in values of X and Y into here, I would get the profit out, depending on how many MP3s and how many DVDs I sell. Okay, so I've dealt with that first 2 sentences there. Now let's look at the next sentence. The next sentence says, the company must manufacture at least 10 MP3s, at least 10 MP3 players per day. So how would I write that as an inequality? At least 10. Yes, X is greater than or equal to 10. But it also says no more than 50. So how would I write that? X is less than or equal to 50. Or we could write it as like a compound inequality there and put the 50 on this side, but I kind of just like to keep them separate there. Either one is fine though. Oops. So now we've dealt with that sentence. Now let's look at my third sentence there. It says, the number of DVD players produced cannot exceed 60 per day. Number of DVD players cannot exceed 60. So how would I write that? How does y relate to 60?
Y is
Less than or equal to. And the trickiest one usually for people to do is it says the number of MP3 players cannot exceed the number of DVD players. So MP3 can't exceed DVDs. How am I going to write that?
less than or equal to 60.
Excellent. It is less than or equal to just y in general. Okay? Yeah. Okay? So now I've got all of these different constraints. This is what I'm going to use at the very end. I'm not actually graphing the 30x plus 70y because I have no equals what. Okay, can't graph that if I just have 30x plus 70y. So I am going to graph all four of these things on my graph here. Okay. Since we're going up to 60, let's just go by tens. Is that okay on my number line there? So that way we can fit them all in. So I'm gonna, go by tens here. So if you ever have to change the label of your graph, that's fine. Just at least label the first few so that way I know what you changed it to. And also it will help you as well, remember, when you're finding what those values of those points are, okay? So I'm gonna start with that first inequality. X is greater than or equal to 10. So we graphed these last class. So at 10, on the x-axis there, I'm going to have a vertical line. And it will be solid, right? And then if it's greater than or equal to, which direction am I shading? To the right or to the left? If I plug in a point there and I test it.
To the right.
Yeah, it would go to the right. Because if I tested a point, if I tested 0, 0, is 0 less or greater than or equal to 10? No, so I'm not shading on the side with 0, 0. I'm going to shade on the other side. So that means everything over to the right is part of my solution so far, okay? Let's throw in the other one there. I've got x is now less than or equal to 50. So at 50, I'm also going to have a vertical line. And it says less than or equal to. So if I tested a point there, test 0, 0 again, is 0 less than or equal to 50? Yes, right? So that means I am shading to the left or to the right? To the left, right? So that means everything over here. So far my overlapping is this in the middle here. Okay? And I've got that pink line there. I've got y is less than or equal to 60. So that means at 60 on the y-axis here, I'm going to have a horizontal line. And these are all solid because they're less than or equal to, greater than or equal to, and things like that. And then I got to test a point. If I plug in 0, 0 here, is 0 less than or equal to 60? Yes, so I'm shading everything down below. But my shared region so far, all I really care about is this stuff in the middle here. That's my solution so far. Okay. And then the last one that we have here is x is less than or equal to y. So this was actually one that was on your little mini quiz, except for it was negative x. So if I have y equals x and I was graphing that, I would start at 0, 0, and then where do I draw my next point? Up 1 over 1, right? Or in this case, it's up 10 over 10. So I've got all these points here, okay? And I would draw a straight line, and it will be a solid line through all of those points. And if I test a point there, can I test the point 0, 0 in this case? Nope, because it's on the line. So I'm going to test a point. I'm going to just test 0, 10. So that means I'm plugging in 0 for x. Is that less than or equal to 10? Yes, it is. So I'm going to shade everything above here. So that means my solution is going to be everything in this region. I'm going to kind of outline it here with a black pen. So our region of our solutions is this little trapezoid thing right there. Okay? So we have graphed it. Okay, our step number 3 says that we need to identify all the vertices or all the corner points of our feasible region. So our feasible region is that one that I highlighted there kind of in black outline there. So I need to figure out what are all of these vertex points. So this down in the bottom left, that vertex point is 10, 10. So 10, 10. If I go up to that top left point, that would be the point 10, 60. If I go over across, I would be at the point 50, 60. And the last one just underneath that is at the point 50, 50. Oops. Okay, so now that I've got all my vertex points, I'm going to plug them in to this profit function with my x's and y's to see which one's going to give us the most profit. If you had to guess right now, which one do you think that would probably be? 50, 60. So we think 50, we think 50, 60, this point right here. Or maybe you think, oh wait, no, this point right there, sorry. Okay, so we're gonna test our points, okay? I need to see this on your test question as well to make sure you're testing all of your points. It might, like on a homework question, it might not be asking to maximize profit. It might be asking to like minimize cost or something like that, okay? In which case you would be looking at the smallest answer of your vertex points, okay? So I'm gonna go ahead and plug these values in. So I'm plugging in my x value of 10 into this function and my y value of 10 into this function. And when I do that, I get an answer that I have written down somewhere of, I think it was 1,000. That sounds right. 1,000, okay? So in my calculator, you plug that in, we get $1,000. Okay, same thing with these next 3. Plug in your x value, plug in your y value. Give you guys a second to plug those in your calculator, evaluate all 3 of those points. All right, did you guys get the same values that I did up here? Yes? Very good. So that means obviously here we can tell our function that's going to give us the maximum, or the point that's going to give us our maximum profit is when x is 50 and y is 60. So let's answer what those x and y's have to be. X is my MP3 players. So that means I would need to sell 50 MP3 players and 60 DVD players to maximize our profits. Okay, so after you've graphed everything, you've shaded correctly, you found your vertexes, make sure at the end you answer the question, okay, whether it's maximizing profits or if it's minimizing costs. If this question was about minimizing costs, I would have actually chose the point 10, 10, right? And on your quiz or on your test, I want to see these 4 points or however many points are on your feasible region. I want to see what those values are when you plug them in, okay? All right. Now, the next example that's on the notes, I don't love it, so we're not going to do that one. We are going to do the one that is in Schoology, so go grab that one from Schoology for me. It's about a farm. I'm going to go grab it real quick here. Okay. This is the one that is going to be very similar to the question on your test. Okay, there's only one linear programming question on your test, and it is very similar to this one. So again, all these linear programming things have a lot of constraints, okay? There is one either profit or objective function that we need to write as well, in addition to writing our variables. So let's read through this here real quick. We've got Green Thumb Annie wants to grow pumpkins and strawberries. She wants to grow no more than 60 total plants with no more than 40 strawberry plants. With proper watering and fertilizer, Annie will use $100 for all of the pumpkins and $50 for strawberries. She has $5,000 available for this purpose. Find Annie's maximum profits if she makes $100 per bushel of pumpkins and $80 per bushel of strawberries. Indicate how many pumpkin and strawberry plants she could grow to maximize her profits. Okay? So what are my two variables? Tell your neighbor real quick. You have someone behind you. Strawberries and pumpkins, right? So X strawberries, Y is pumpkins, or you could do vice versa. It doesn't matter. Sound good? X is pumpkins, yeah? And Y are strawberries. Okay. So I know we've only done one of these examples. You have seen this before. I want to give you guys a few minutes right now to try out writing as many of those constraint inequalities and maximize profit function as you can, okay? And then we'll talk about it here in about 3 to 5-ish minutes, okay? So help each other out. Reread the problem and write as many as you can, okay? Is the fact that no one had X greater than or equal to 0 and Y is greater than or equal to 0. Why would I need those constraints?
Because it's a real life thing.
Because it's a real life thing, right? I can't sell negative pumpkins. I can't sell negative strawberries, okay? So we want to restrain our stuff just to the first quadrant, okay? So we can go ahead and just say, we could say X is greater than or equal to 0, Y is greater than or equal to 0. And then there are no, I kind of hate this graph, but that's okay. We'll work with it. Because it's just a giant grid, there's no lines on it. So let's just call this our first quadrant. So I'm just going to go ahead and put a little axis there and an axis here. Okay, so this point down on the bottom is going to be 0, 0. Okay, we okay with that? Cool. All right. So let's start with our profit equation real quick. Okay, our profit, we're maximizing our profits. How much does she make per strawberry and per pumpkin? It says maximum profits is $100 per bushel of pumpkins and $80 per bushel of strawberries. So my objective function, or the maximum profits is going to equal 100x plus 80y. Okay, that is what we're going to test at the very end. Now we got to talk about all the other constraints out there. A lot of us said she wants to grow no more than 60 total plants. A lot of us said X plus Y is less than or equal to 60. Do we agree with that?
Yes.
I do. X plus Y is less than or equal to 60. Okay, that deals with that first sentence there. Next one says, and a lot of you had this one as well, it says no more than 40 strawberry plants. So no more than 40, I would write that as Y is related to 40 how? Less than or equal to. Okay, next one says Annie's going to use $100 for the pumpkins, $50 for the strawberries, and she has $5,000 available for that. So I would write that as an inequality. So I've got 100x plus 50y is less than or equal to 5,000. And did we account for everything that was given a number in this equation or in this word problem? I do believe so. So 4 total kind of constraints / our objective function. And then this one is not like one that you have to like actually have written down. The X is greater than 0 and the Y is greater than 0. But we do need to like show that in our graph. Okay? Because we're talking about real numbers and real things. So now I just got to graph all these things on here. Okay? Do you guys remember last time when I said it's probably going to be easiest to graph your X and Y intercepts in this case? Okay, all of the ones that we're going to do on your homework and on your test are going to cross nicely in the middle at one of those points. But using your X and Y intercept will be the quickest way to graph it. So when I am finding my X-intercept, let's do the blue function here first. My X-intercept, if I want to find that, I would plug in 0 for Y And what is my x-intercept going to be?
0, 60.
For x-intercept, it'd be 60, 0, but yes. For my y-intercept, same thing if I plugged in 0 for y, or sorry, 0 for x, I would get what for y?
0, 60.
Also 60. Yes, 0, 60. So I've got 60, 0, and 0, 60. Let's go graph those on this graph here. Now, are we going to be able to count by ones? No, I don't think so. We could probably count by 5s if we wanted to, but we can just count by 10s, honestly. That's fine with me. So let's go by 10s here. So I've got a point at 60, 0. And I've got a point at 0, 60. And between those 2 points, am I going to have a solid or a dashed line? Solid line. Okay, and I need to test a point. So if I plugged in the point 0, 0, is 0 plus 0 less than or equal to 60? You betcha. Okay, so we're going to shade everything below our line. So everything down here. Okay. First equation done. Second equation is y is less than or equal to 40. So that means on the y-axis at 40, I am going to have a line that goes through the y-axis here. It will be a solid line because it is less than or equal to. And if I tested a point 0, 0, if I plug in 0, is 0 less than or equal to 40? Yes, it is. So I would shade everything below this line here, okay? But really, all I care about is that part that is being shared with the blue. So technically all of this is shaded, but I just care about where it's intersecting, okay? So that purplish region there, so far as our solution set. Now, next one here in pink, I've got 100x plus 50y is less than or equal to 5,000. So I want to find my x-intercept and my y-intercept. So for my x-intercept, I am going to plug in 0 for y. If I plug in 0 here, I have 100x is less than or equal to 5,000. So what is my x-intercept going to be? 50. Yeah, get rid of those 2 zeros, right? So your x-intercept is 50. So 50, 0. If I want to find my y-intercept, I plug in 0 for x. And what is my y-intercept going to be? 0, 100. So now I can plot those on my graph. Will it be a solid or a dashed line here? Solid. So at the x-axis on 50 and the y-axis at 100. Solid line between those two. Okay. Like I said, your solutions should cross at a pretty nice point, okay? As we can see, oh, we forgot to shade. We first have to shade. If I test a point, if I test 0, 0 back here, is 0 plus 0 less than or equal to 5,000? Yes, it is. So I'm shading everything below this line here. So that means that my solution is everything that I'm going to outline here in black. Okay. That little weird looking slight trapezoid with the thing cut off there, that is my solution set. Okay, so like I said, it's going to cross at very nice points. So I need to identify what are all of my vertices here. Okay, so my vertices, I would be 0, 0 is the bottom left. Top right would be 0, 40. Moving on over there, I would have 20, 40. Then I go down a little bit there. It's at 30, comma 30. I think that's wrong, actually. My graph is a little off when I plotted that. Did I do it wrong? Yeah, shout out to Mr. Lauritsen. Explain Everything is trash, so you should not use it. But, so this actually, let me kind of fix this. This should be crossing. Oh, that's not letting me erase it. Okay, ignore this point. That's wrong. Okay, it should actually cross right here. So this is my region. That was bad. Okay, so this is actually at 40, comma 20. And then our last point there is at 50, comma 0. Okay, if there was ever a time where it like did not cross exactly on your graph, how could I figure out the solution of two intersecting lines?
Something in your calculator?
Systems of equations. You could also plug it in your calculator. You have two equations of two lines, right? The solution of a system is where they intersect, right? So I could find a point if it did not cross nicely on your graph. But the ones on your test and the ones on your homework should be graphing nicely on your stuff, okay? So that point, again, I'm just going to write it in here. This is wrong. It should be at that point right there, okay? So I've got all these points. My objective function, again, was the 100x plus 80y. That is maximizing our profits. So can I just get rid of 0, 0? Yeah, that's not going to make you any money, right? Well, let's go ahead and test these other points here. If we had to make a guess, what do you think the maximum profit's going to make? 40, 20. Okay, let's test our theory. Plug these in for your x and y. So I'm plugging in x is 0, and I'm plugging in y is 40. And then I'm doing that for all of these points, plugging in their respective values. So give you a minute, plug these in, see what you get. All right, these are the four values that I got. So I do agree with you guys that 40, comma 20 is going to give us our maximum profits, but 40 stands for, in terms of our problems, what? Pumpkin. So 40 pumpkin plants and 20 strawberry plants should be grown to maximize profits. Okay, now again, make sure you read, yes, the two that we've done were maximizing profits. Make sure you read the question on the homework because it might be about minimizing cost, in which case you want the smallest number instead of the maximum number, okay?